Hi, you guys. Welcome. My name is Caitlin. Lots of you may know me, but some of you may not. I am a tutor in the South Anchorage area. And before this whole pandemic thing, I had students that were in Algebra 1, Algebra 2, geometry, that kind of thing. And so I'm trying to put out some videos that are going to help them get through this. Now, of course, and so anybody's welcome to use these. Of course, do whatever your teacher has told you to. But if you are enrolled in Algebra 1 this semester, you likely haven't hit the last couple of units, which are really important. And I wouldn't really say that you've fully completed Algebra 1 until you've done those. So for most of you, you ended up in Unit 9, which was factoring. We did a whole bunch of factoring right before spring break and right before this extra break. After factoring comes Unit 10, which is dealing with quadratics, and that's parabolas and things like that. You really have to know your factoring in order to succeed in this new unit, unit number 10. So what I'm going to do today is do a quick review on factoring, and then we'll jump right into Unit 10. Now, like I said, do whatever your teacher is telling you to do. If you're in the Anchorage School District, you're probably using this version, this book. It's got the kayaker on the front, right? You can see my ring light. It's got the kayaker on the front there. Like I said, we are in Unit 9. Maybe your teacher doesn't use a book. It doesn't matter in Anchorage School District if you're in grade 8, 9, 10, 11, whatever. If you are enrolled in Algebra 1, you are usually given this book, but a lot of teachers use like supplemental worksheets and that kind of thing. However, they're paced pretty close together. So you should be right around here. So what we're going to do today, like I said, we're going to launch right into that factoring, and then we're going to do some quadratics. So let's get started with that. Now, down below in this link, you'll see a copy or a link to this worksheet here. The one that I printed, the link that you're going to see it's not going to have a whole lot of room for you to write in. I did that just so I don't have to, you don't waste time with me writing these down, watching me write these down. But you'll need to use paper. I just wanted to make it as small as possible for your parents. Also, guys, the answers are attached to the back. I don't care about the answers. I just want to make sure you know this stuff. So for the first 30 problems, 1 through 30, we're going to factor out the greatest common factor from each expression. Now, guys, chunks are broken up by addition, subtraction, right? So we got 3 chunks here. All 3 of those chunks have a couple things in common. The first one is 7. 7 can be factored out of each of those. The other thing is x. There's 3 x's here, 2 x's here, 1 x here, which means the most that we can take out is just that 1 x. So what do I need to multiply 7 by to get 63? 9. What do I need to multiply x by to get x to the third? X squared. Minus, what do I need to multiply 7 by to get that negative 56? We've got 8. And x times x will give me x squared. And then plus 10, because 7x times 10 will give me that 70x. So this is just factoring out those greatest common factors. So let's try this one. Looks like we're on a roll for 7s today. 7, and then there's k3, k2, k1. So we're just going to take out 1k. That leaves us with 7k squared, because if we were to distribute now, 7k times 7k squared would give me 49k to the third, plus 7 times 2 will give me 14, and k times k will give me k squared. Plus, now this is really important. What do I need to multiply 7k by to get 7k? I have to multiply it by 1. We have to have that 1 placeholder there, okay? Don't just close it off right here, because you have to have something to distribute that to. If you wanted to go through and check your work, you could absolutely do the reverse. This is basically reverse distribution. And so you can do distribution property, right? We say, hey, this garbage times this garbage gives us 49k to the third. This garbage times this garbage gives us plus 14k squared. This garbage times this garbage gives us plus 7k. And is that what we started with? It absolutely is. So this is correct. That is your answer. Go ahead and pause the video, try number 3 and 4, and then come on back. Okay, so we are really on a roll for 7s. I'm so sorry. I didn't double check these. This is 7, and there's 1 in here, 5 here, 6 here. I can only take out 1. This is going to be 7 times 9 gives me 63. N times n to the 5th gives me n to the 6th. Remember, n times n squared gives me n to the third, right? So we add, like this is a 1 right here, right? So we add, even though we're multiplying our bases, we add those exponents. Add those exponents. Okay, so that was the first part. Plus 8 times n, because 7 times 8 will give me 56. N times n to the 4th will give me n to the 5th, plus 10. All right, there we go on that guy. Now, for number 4, it looks like we can take out just a 5, right? So we get 5. That leaves us with negative 4, I don't know why I had to think about that. Sometimes that happens. Negative 4 plus 1m, but I'm just going to leave it as m. We don't want to put a 1 in front of that. If the only time you should put a coefficient in number in front of the variable is if it's something other than 1. Then 5 times 5, what do I need to multiply 5 by to get 5m squared? Well, 5 times 1 would give me 5, so I'm not going to put a 1 there, but then m squared. Now, guys, what I want you to make sure you're doing is writing these in standard form. And what I mean by that is you take each one of these chunks called terms, and you want to start with the highest exponent first and then work your way down. So we're actually going to rewrite this as 5 on the outside, but see, our m squared is our highest one here, plus m, because that's this one right here, and then minus 4 because it's a negative 4. This would technically be the proper way to do this. Now, it's not written that way on the answer key, but that is a good habit to get into. So just keep that in mind. Keep that in mind. All right, so basically 1 through 30 is just going to be a whole bunch of these that we've just done. You're practicing taking out that greatest common factor. So I gave you a whole bunch of it. You don't have to do them all. It's just a way for you to practice to make sure you know what you're doing. So let's jump to number 31 here. So these are called special cases. Special cases. And guys, I want you to write this down in your notes somewhere. You're going to have x squared minus y squared equals x plus y, x minus y. This is called your difference of squares. Difference of squares. Okay, so then, and occasionally my dog likes to come say hi, and he's wandering over here. So we're going to introduce my dog. Like, come here, come on, you come up, come on, come on. This is Boris. He's my dog. He likes to interrupt videos. He waits until I'm talking, and then he wants to sit on my lap. So, all right, buddy, get down. Okay, so the difference of squares. That's a big one that you're going to need to know. Okay. Now the other one we're going to want to know is called the perfect square trinomial. So I'm going to put that right there. And then we're going to do perfect square trinomial. And the way that this guy works, okay, is it's going to be, let's say we have x plus y squared. That is going to equal x squared plus 2xy plus y squared. If this looks confusing, no sweat. Once you see a pattern, it's a little bit easier in my opinion. So that's going to be this guy right down here, perfect square trinomial. All right, so what does that mean? First, we're going to jump around on this page because I want to talk about that difference of squares first. I think if we get something squared minus something squared, remember difference means subtract, then we're able to break it out into this lovely little pattern here. So take a look at 32 here. We have something squared minus something squared. What do I need to put in here to give me 25n squared? Well, I've got to put 5n. 5n. What do I need to put in here to give me 9? 3. Therefore, this guy right here factors down into 5n plus 3, 5n minus 3. Now, if you wanted to check your work on this, you could FOIL it or distribution, where you do this times this times this, and then you do this times this times this, and that gives you, you would get the same answer. You would notice your inside, your outside would factor out. You would end up with negative 15n, positive 15n, and those would cancel out. So you're just left with your first and your last. That's why this works out this way. But it's good to just, math is all about patterns. Learn to identify those patterns. So I'm going to flip through around on this page because what I'm looking for is one that has a two-parter here, a binomial, right? There's 2 of them. Let's turn to number 42. We're going to do that one. Okay, so this is a binomial. So I can do something squared minus something squared. Something squared minus something squared. In the first one, I need to put 3a. And then in the second one, to get 1, I'm going to put 1. That means this guy right here factors down into 3a plus 1, 3a minus 1. 3a plus 1, 3a minus 1. Let's try another one. Looking at number 47 here. Get something squared minus something squared. Okay? We get 5a and 2, because 5a squared would give me 5a or 25a squared. Because remember, we're distributing that 2 to the a and to the 5. Be careful about that. And then 2 squared is 4. That means this breaks down into 5a plus 2, 5a minus 2. All right, guys, try number 46 and 48. So pause the video, try numbers 46, 48, and then come on back. All right, this time I'm going to do it without putting in those, that something squared minus something squared. If you did this correctly, you should end up with plus, minus, and the first one is going to be 4n. And then our last one is, the square root of 1 is just 1, so we're going to do 1 and 1. Oop, I made the mistake there. That should be, 1 should be plus, 1 should be minus. Make sure I didn't make that mistake on the other ones. Okay, so same with this guy. This is going to be a plus 1, a minus 1. Excellent work, guys. Excellent work. Okay, so now let's talk about, so there's other ones to practice on those, but let's talk about these perfect square trinomials. Perfect square trinomials. What I want you to do is get in the habit of when you see a perfect square at the front and at the back. Now, let me back up and say standard form. Probably help if you can see it. Standard form is ax squared plus bx plus c. Okay, so our a is, this is our quadratic term, this is our linear term. Remember when we talked about lines, y equals mx plus b, that's this guy right here. And this is our constant, it doesn't change, there's no variable to change it. So when your a and your c are perfect squares, and remember your perfect squares, 2 times 2, 3 times 3, 4 times 4. It's a good idea to have a cheat sheet handy so that you can double check those. But when your a and your c are perfect squares, much like this case up here, it's probably a perfect square trinomial, and we're gonna double check that. What that means is we take this squared, okay? It's gonna be, this first one is gonna be 2n, and then the square root of 1 is just 1. Now, the way that we would double check this is, if you see a perfect square trinomial like this, you could cross this out and rewrite 2n plus 1, and then do first, outside, inside, last, you know, foiling or distribution or whatever you wanna do there. However, there is a pattern here, and the pattern is you take this guy in the front and you square it, so we get 4n squared. Then you take this guy and you square it in the back. Positive 1 squared is positive 1, right? 1 squared. So, and then what we do is we take 2n times positive 1 is 2n. We multiply those two things together, and then we double it. 2n doubled is 4n. And do you see how this is what we started with? Therefore, this is your answer. This is your complete factor one. Lots of kids get hung up on this, and that's okay. It's not the end of the world if you don't see it, but it will help you factoring later if you can identify when you see a perfect square trinomial, because if you get really big numbers and you're having to factor those by grouping, you're gonna be miserable if you don't see that it's a quick perfect square trinomial. So we're gonna do a bunch of these. Okay, so let's look at this guy. Perfect square here, perfect square here. So it's probably a perfect square trinomial. This guy would be 3x, and this would be 4, the square root of 4 is 2, okay? Now, the sign that goes in here is whatever this is, because watch this. Now, first is 3x squared, so that's 9x squared. Last is negative 2 squared. Negative 2 times negative 2 is positive 4, so plus 4. And then you take these two things, multiply them together. So negative 2 times 3x is negative 6x, and then double it. Negative 6x doubled is negative 12x. And look at, that's exactly what we started with. So this is our answer. Let's try some more. Number 35. So see, this is a good one. If you were factoring this by grouping, and we'll get to that in a little bit later in this video, you would have to do 25 times 9. Ain't nobody got time for that. It's like 225, something like that. And then you gotta find all the factors of 225. Oh, we'd be here all day. Guys, I'm lazy. I'm gonna show you the easiest way to do things. I can't be bothered. Okay, so, but what we do know is that this is a perfect square and this is a perfect square, so let's give it a perfect square trinomial, perfect square trinomial. Words are hard today. Okay, so we know that this guy is gonna be 5b, and then we know this guy here is 3. Then we use whatever that first sign is, plus. So let's just double check our work. We know our first and our last are right, because we just did that, right? 5b times 3 is 15b. Double it, you get 30b. Yeah, all right, we're on this. Let's look at this guy. We've got 16r squared and 9. So this is probably a perfect square trinomial. And now it doesn't always work that way, so you always have to double check. But we'll use this sign, plus, and then the square root of 9 is 3 squared. Now, 4r times 3 is 12r. Double it, you get 24r. So this is our answer right here. Excellent. If you guys have questions, please do not hesitate to let me know. I'd be happy to help with that. Those special cases, the difference of squares and the perfect square trinomials, that's numbers 31 through 60. So I want you to double check your work, make sure that you've got some of those. Maybe just do all the odds or something to make sure that you've really got that down. Let's move on to 61, number 61. Okay, so let's look at these guys. Okay, the leading coefficient is 1. So in these guys, that's a dumb one. We're not going to do that. In these guys, remember I said standard form is ax squared plus bx plus c. That means your a is always going to be 1. And if you'll notice for these guys, these are all going to be 1, right? So taking a look at number 62 here, this guy is going to be, the way that I do these is, I'm very methodical about it because there's many different ways to factor. I just happen to do the same way every time. Hold on one sec. Okay, sometimes my dog bugs me and I have to pause. Okay, so like I said, I do these the same way every time. Here's what I do. When your a is 1, you draw your bubbles, parentheses if we're going to be technical. You throw in your first, n, n, n. Remember when we're foiling, we do first, outside, inside, last, or distribution method. So we know n times n is going to give us n squared, so that's fine. Then what we have to do is determine our signs. Guys, 90% of the problem here is determining your signs. If you know what your signs are, it makes these problems like 90% easier. So what we do is we look at this one. If it is negative, then it's going to be different signs. If positive, it's always that last one. Look at that last one. If it's positive, same signs. That means it's either going to be positive, positive, negative, negative. You got to look to the first one. So same signs, look to the first one. Okay, this will make more sense as we go along. So this is negative, so that's going to be different signs. So we've got positive, negative, does not matter the order. You can put positive first or negative first, I don't care. Then your next step is to list all of your factors of 16. We have 1 times 16, always go in order so you don't miss any. After 1 comes 2, 2 times 8. After 2 comes 3, 3 does not go into 16, but 4 does, 4 times 4. There's all our factors. So I need a positive and a negative that gives me negative 6. So I'm going to do positive 2 and negative 8 because positive 2 plus negative 8 would give me negative 6. So positive 2 and negative 8. This is your factored form. Now, if you are doing this on your own, I highly advise that you double check your work by factoring or by foiling it, right? So if we were to double check this, we would do first, which would be n times n, which is n squared. Outside, which would be negative 8n. Inside, which would be plus 2n. Last, which would be minus 16. Combine those guys, you get n squared minus 6n minus 16. Is that what we started with? Absolutely. So then this is your correct answer here. So let's go through that again. Here's what we get for number 62, 63, whatever this is. And to be honest, this is driving me nuts if this is in a packet, so I'm going to fix that. Bear with me here. Okay. So for this guy, we're going to put up our bubbles, okay? And then we're going to put in our n's. Then we're going to look at our signs. This is negative, so we don't have to go any further. We know our signs are going to be different signs. Positive, negative, doesn't matter the order. 24, list all our factors of 24. We have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 4 times 6. Those are all our factors of 24 because after 4 comes 5. 5 does not go in. After 5 comes 6. 6 is already up here, so we're good. Now, what I need is a positive and a negative that gives me negative 2. Well, how about positive 4 and negative 6? That would give me negative 2. So positive 4, negative 6. There you go. You have factored it. Again, if you're on your own, make sure to foil these to double check. But otherwise, you're doing great. Let's do this guy. First step, bubbles. Second step, this guy right here, n. N. This tells us different signs. And then factors of 7, 1 times 7. I need a positive and a negative that gives me negative 6. Positive 1, negative 7. That'll give me negative 6. Positive 1, negative 7. Excellent work, my friends. I hope that works for you. Try number 65 on your own. Pause the video and then come on back. All right, so we got bubbles. We got B. This tells us different signs. Plus, minus. Factors of 20. We have 1 times 20, 2 times 10. Not 3, but 4 times 5. After 4 comes 5. It's already on the board. We're good. We need a positive and a negative that gives us positive 1. So how about positive 5 and negative 4? That'll give us positive 1. Perfect. All right, guys, so let's talk about when it is not. Now, oh, look at this is a special case that we just talked about. Perfect square, perfect square. Guess what? This is going to be p plus 7, p minus 7. This is a difference of squares. Difference of square. I don't even know if I'm spelling that right. This is not spelling hour. This is math hour. Difference of squares. Guys, if your middle term is missing, you're like b, when we talked standard form, ax squared plus bx plus c. If that b term is missing, it's probably a difference of squares, probably. Or they just want you to factor out a greatest common factor. So keep that in mind. Okay, so let's talk about some of these that have positives now. Look at this guy down here, 36. That's a positive right here. So what we know is bubbles, v, v. This tells us same sign, so it's either going to be positive, positive, or negative, negative. You have to look to the front. If you think of it like when you see an X here, draw a little arrow that points here, negative, 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 negative. So now we need factors of 36. So 1 times 36, 2 times 18. I'm totally going to make a mistake on one of these. You're going to have to tell me. 3 times 12, 4 times 9. After 4 comes 5, not 5. After 5 comes 6, 6 times 6. And then we're repeating ourselves, so we're good. Okay? Now, I need a negative, negative. That gives me negative 13. Negative 4, negative 9. Negative 4, negative 9, and that is your answer. So you got to be real careful with your signs on these, okay? Now, why am I showing you? Your teacher may have shown you something different, and that's totally fine. I'm going to reach. And that's absolutely fine. Do whatever your teacher says to do. But in this next unit, unit 10, when we talk about quadratics, holy cow, if you do not know how to factor like this, it is going to be so painfully slow. So I want you to feel like you can factor straight away. Here's one that's missing its b term. Y'all, it's missing its b term. That means it's probably a difference of squares. Sure enough, perfect square, m plus 8, m minus 8. All right, let's take a look at some of these other ones that have positives. Let's look at this guy. This has a positive right here. So let's do our bubbles, and let's do our letters. Now, this tells us same sign, so we draw an arrow. This tells us positive, 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 positive. I didn't leave a whole lot of room there. 1 times 70, 2 times 35, 3 times, I don't know all these off the top of my head. So 70, 70 divided by 3, no, 70 divided by, well, of course. Do you know this trick? 70, I wanted to see if 3 went into 70, and I did it on the calculator for some dumb reason, but 7 plus 0 is 7. 3 does not go into 7, so 3 is not going to go into 70. Good trick. 70 divided by 4, I get 17.5. I don't want any decimals, so not 4. We definitely know 5, though, because it ends in a 0, right? So 70 divided by 5 gives me 14. So 5 times 14. After 5 comes 6. 6 does not go in. After 6 comes 7. 7 times 10. After 7 comes 8. 8 does not. 9 does not. 10 does, and it's already on the board. So these are all of our factors. So you see that pattern, how I'm looking for all of my factors and putting them in order? It's a really good idea. Put them in order like this, because 9 times out of 10, it's somewhere down here at the bottom. So I need a positive, positive that gives me 17. And hey, sure enough, look down there at the bottom. Positive 7, positive 10. 7, 10, bam, you are done, my dear. Let's look at another positive here. 50. I like this. Number 79. We got 50 here. Bubbles, bubbles, n, n. This tells us same signs. This tells us positive, positive. Factors of 50, 1 times 50, 2 times 25, not 3, because 5 plus 0 is 5, and 3 does not go into 5, so 3 is not going to go into 50. 4? No, that'd be 12.5, right? 50 divided by 4. I'm just testing. Yeah, ooh, I was actually good on that. Okay, not 4, but 5. 5 times 10, right? After 5 comes 6, not 6, not 7, not 8, not 9, 10, yes, and it's already up there, so we're good. So I need a positive, positive that gives me positive 15, positive 5, positive 10. Bam, bam, you are done. Excellent. All right, guys, so so really, I've put all these other pages of practice on here for you because y'all need to know how to do this like straight away, okay? So let's see, 82 is a dumb one. I forgot to double check these before I did it. So this one's kind of dumb because you take out an r and you just get r squared minus 5. But you can't really do anything with that information because that's not a perfect square there. It would be nice if that was a 4 because that's a perfect square, but it's not. So I probably shouldn't have had that one on there. I should double check before I post this. Okay, Let's look at one more with a negative down here, 60. I love 60. Let's do it. Bubbles, B, B, and this tells us different signs. Perfect, we don't have to go any further. Now, 1 times 60. The hardest part is just listing all your factors. And you should know when I teach my 6th, 7th, and 8th graders, I am like, you better know your factors. You better come into my class knowing your factors because this is a pain otherwise. I don't know why I picked up my calculator. We've got 2 times 30, 3 times 20, 4, 60 divided by, oh yeah, times 15, right? Yep, 4 times 15, 5 times 12, 6 times 10, not 7, not 8, not 9, and 10's already up there, so we're good. Yep. Now, we need a positive and a negative that gives us positive 4. Well, does any of these have a difference? Oh, yeah, look at that. We need positive 10 and negative 6 will give us positive 4. That's what we need. So, negative 6, positive 10. Bam, there's your answer. All right, guys, so that is my crash course on factoring. Practice, make sure you know that, and then we will start in on quadratics next video. Thanks, guys.